In this video, I'm going to be testing these two monitors from the mid-80s that I found at eWaste. I want to find out if they actually work, of course, but then I also want to see how monitor manufacturers dealt with the rapid evolution of video standards from MDA to CGA to EGA to VGA. It all happened very quickly, so we'll take a look at these monitors and see how they perform. It's coming up right now on the Retro Hack Shack. Well, hey there everybody, welcome back to Retro Hack Shack. My name's Aaron, thanks for joining me, where I take a look at mostly retro computing stuff, but also all kinds of other things as well. In fact, I'm working on a Betamax player right now, which will hopefully appear on this channel soon. But today I'm going to be taking a look at some monitors. And in case you missed it, over on my second channel, a lot of good videos over there, Retro Hack Shack After Hours. It's been a while since I've done any videos, and that's because I've been out celebrating two graduations. My youngest from high school, my middle from college. And then when we got back, got hit with COVID. So that really kind of put me down for at least a good week and a half. I'm still struggling. You can probably hear it in my voice. Also, I'm in between jobs at the moment, and so I've had to spend a lot of time basically selling stuff. And there's a great electronics flea market that's been around for 50 years here in the Bay Area. I've been taking some stuff down there. So if you happen to see me at the next one, come over and say hi. But yeah, so all of that has taken up a lot of time, and it's been a while since I've released a video. Now you may be wondering why we're going to be talking about this monitor here, which is a Taxan monitor. I'll get to that in a minute. On my second channel, a couple eWaste Wednesday videos ago, perhaps you can see over in the corner, I discovered this HP Vectra computer, and I'm going to be going over that in a lot more detail and restoring it. But I don't have the original HP monitor that was sold with it. And I do need something that is at least CGA, I believe it would be correct for that particular computer. And so today I thought I would pull this one out and have a look. Like I said, this is a Taxan RGB Vision 420. The RGB here really is RGB. So this would have been appropriate, I believe, all the way up to EGA. It's got a brightness knob here on the front. It's got a big chunky power button that's actually really nice. It's not flimsy at all. I love seeing details like that on these monitors. And that's about all you can see on the front. Interestingly enough, on both of the sides here, there is a screw, which is apparently for disassembly. And it says, "Caution, do not remove cover. See markings on back." Taking a look at the back here, we can see a lot of interesting things. We do have those cautions and warning, as the sticker told us, but it also shows us that this is a Taxan, not a Texan, but a Taxan 12-inch color display. But it also says down here, EGA Electronics Company Limited. So this monitor, well, as it says right here, was made in Japan by a company called EGA. And that's actually very helpful if you want to look up information on this monitor. Also, we can see the inputs here. It's got one of these, I would say, Sony style or Japanese style connectors that were made. You'll see a lot of these on old Sony CRTs. It also has an 8-pin DIN right here as well. And up above here, it has a little legend telling you what those modes are. So mode number 1 is IBM PC. And down here, it says that you would use this 8-pin jack for that mode. Mode number 2 is either an Apple II or an NEC PC 8001. So that would be what this big jack here was supposed to be used for. And then, interestingly enough, this really tells you when this particular monitor came out. Mode number 3 was an Apple III, and you would use that same connector, but maybe something different on the other end for the Apple III. But I find that to be pretty interesting that, you know, it just so happened that this monitor came out at just the right time to catch some of the Apple III hype, and so they actually made a mode specifically for the Apple III. Now, I believe if you wanted to hook this monitor up to an Apple II, let's say, I'm not sure about the NEC PC 8001, but I believe the Apple II, what you would have, I believe they also made a separate card that would plug into the Apple II, and a special cable that they sold as well, and then you could hook up this to an Apple II, but you would need that card. You wouldn't just be able to hook it up directly to the composite output. And then of course we have like a little ground connector down here and the plug, which is still attached. So many times when I go to eWaste, these cables are immediately cut off and I have to wire a new one. Not so in this case. this actually still has the cable attached. So thank you to the e-waste folks for catching this before that happened. Down here on the very bottom, perhaps you can make out there are also some adjustments for the monitor itself. And I'm sure that will be things like vertical hold and centering controls, et cetera, et cetera. And I just went ahead and put it on the bottom to see if there was anything interesting on the bottom. And indeed there is. It's actually a day code here. So this was manufactured in March of 1985. So there we go. Now, one more thing before we begin, as I was doing just a quick visual inspection, I noticed that the cable, the power cable, even though it's intact and hadn't been cut off by e-waste, it looks like it did get caught underneath something. And I don't think this is broken all the way through. I think mostly just the insulation here has come off, and it looks like it's just affecting one conductor here, if anything, but it looks like it's still intact. It doesn't look like too much of a problem. I'm going to go ahead and put some electrical tape over this just to be safe, but I think that'll be okay. I may want to replace this cable anyway in the future, and we'll see if that causes any problems when we go to test this thing up. All right, well, I wish I had contrast control in addition to brightness, but the monitor's plugged in. Let's just go ahead and do a first initial test, see if we get any magic smoke. Okay, I heard high voltage, and I've got static on the screen. So that is a really good sign, and we've got raster. Wow, that is really bright. Look how bright that can go. Now I see on the camera that there is some rolling. That's natural when you don't have a signal plugged in, but once we have a signal plugged in, that should go away because I can match that up with the speed, the shutter speed on my camera. But yeah, this is looking really, really good so far. Whew, yep, I got this thing back up on the table. This is the 5170 that I did a video about not too long ago, and it is heavy, and I'm out of breath just getting over the COVID. I still have symptoms, and they'll probably stay with me for a while, unfortunately. But now that I'm all out of breath, I was wondering how I was going to hook this monitor up, given that it doesn't have a standard 9-pin connector on it or a dedicated cable. I actually have this cable I made to connect my Commodore 128 to a Commodore 1084S monitor that happens to have this same horseshoe 8-pin DIN connector on it. And I looked it up online, and I'll put a little pinout on the screen, but it's the exact same pinout because I was also able to find the manual for the Taxan, and I was able to look up the pinout for the Commodore 1084S monitor, and it's the exact same pinout. So somewhat of a standard there, at least for a little while, at least in the 1984-85 period. So I just went ahead and pulled out this cable. I think it's going to work. So let's hook this thing up and turn it on. And yeah, hopefully it'll just work. Okay, monitor's powered up. And if you're seeing those rolling lines, they should disappear when I turn on the computer because it will get a video signal. So let's see what happens. Well, that's not good. So it looks good, but I'm wondering if perhaps the display mode on the video card is set for EGA and not for CGA. This does not support EGA because EGA has twice as much color information or twice as many pins sending the RGB signal out. And 2 for red, 2 for green, 2 for blue, which is how you get 16 colors instead of just 4. But yeah, this doesn't look too good. Okay, now I've got the computer set in CGA mode. I've switched the dip switches. Computer's in CGA mode now, which should be compatible with this monitor. Let's go ahead and turn it on, and hopefully those squiggly lines we got before disappear, and we get some text. Okay, got a nice clear black screen. That's good. And here we go. Counting up the memory. This should have a meg of memory in it. So yeah, it seems to be completely compatible now with the CGA mode coming out of the... In fact, I looked at the card that was in here, the video card. It is an official IBM EGA card. So hopefully you can see that. Let's just do a dir/W because this has a lot of stuff on this old MFM hard drive. And there we go. You can get a good idea of what the text looks like on this. To me, it's nice and clear and sharp. I mean, I could use this all day long and not have any eye strain or anything like that. So this is looking really good to me. Let me see if I can get checklist loaded on this hard drive, and then we can have it run through the graphics test so we can see what colors are working and all that kind of stuff. It should be the normal CGA stuff, but let's just go ahead, if I can do that, and see what it looks like. Whew. Well, it just came out. There was a little bit of a crack after I turned the camera off, and I left for a second, and I just came back out. Now, the monitor was off, but the power was plugged in. And yeah, there's definitely smoke coming out of the monitor here. So I think perhaps there is a reefa in here that blew. So I'm going to have to open this up and check for that, because it just started selling smoke. And I'm like, where's that coming from? It's nearly 4th of July, and a lot of kids have been setting off firecrackers and stuff. And at first I thought it was just that, but no, it's definitely coming out of the back of here. All right, well, got the monitor apart. And before I tell you what I found, just take a look at how clean the inside of this monitor is. This thing is very low hours from what I can tell. There is no buildup at all like you would see on a high hour set on the tube here. This thing is immaculately cleaned. Yeah, this thing is just, wow, unbelievably clean on the inside. So this is a very nice find. And also, this is the other thing I found. No reefa. There is a filter cap here, but it is not a reefa, and it did not blow. So the problem isn't on the monitor, the smell. As I used my senses, luckily I can smell again after having this COVID. The smell is coming from right there. So the computer's still working, but yeah, that reefa is inside the power supply. So I'm going to have to take this whole thing apart and replace that reefa cap, unfortunately. But hey, that's the way it goes. I thought for sure this monitor had a reefa cap right there and it had blown, but nope. This monitor is golden, really in really good shape. So I'm going to put this thing back together. We'll give this thing a look-see on Check-It. Now I can see right away there is an issue here somewhere, because this should be blue on CGA, I believe. I'm used to seeing EGA, but even on CGA, I think this was supposed to be blue and not this kind of grayscale thing that's going on here. So let's just go ahead in here and run the video tests and see what Check-It thinks is going on here. If we look at the configuration, it is seeing the video adapter as EGA, and then it's got EGA switches 0001. That actually matches the configuration that I have this in. So Check-It is able to take a look at the dip switches and see what they're set for. So that is exactly what I have this set for, and that is supposed to be CGA mode, and it's obviously working where it wasn't before in EGA mode. But let's go ahead and run the graphics tests. And interestingly, the graphics test just goes right to the different modes. There should be some color testing here, and there's not. Modes all seem to be working fine, but there's no color, and there's not even a text color. I've seen some cards where for whatever reason they will do the different color text, but they won't do the actual red, green, and blue, or the whatever cyan, magenta, blah, blah, blah that typically comes with CGA. So for some reason, these all look fine in terms of these modes, the size modes, but there's no color involved, which is really weird. Now, I've got a copy of Bard's Thief here, which should run in CGA, which should use CGA graphics. So let's go ahead and fire that up and see what happens when we actually run a program that's calling for CGA type graphics. And there we go. There's CGA graphics running on this monitor, no problem. So for whatever reason, Check-It was not able to display. Maybe there are registers because it's an EGA card rather than a straight up CGA card. Maybe there's registers in there that aren't being set or something. But this program is calling for CGA graphics and colors, and it is getting them. This looks perfectly fine. In fact, it looks really, really good. In terms of quality color, I have no problems. But I am curious why Check-It, that was Check-It 3.0, is not able to do the graphics test and pull up the colors. Seems to be displaying CGA graphics just fine. So not exactly sure what's going on with Check-It 3.0. If you have any ideas of what else I could check on this 5170 with Check-It and the BIOS and everything, if you have an idea, let me know in the comments below and I'll take a look at that. But Yeah, the graphics part of it seems to be working, but on Check It, it doesn't seem to be able to generate the right colors or detect the card correctly to be able to show the colors in the Check It program. So this monitor looks pretty good, but the next monitor we're going to look at actually has a lot more functionality, and it's only about 2 years older. So let's take a look at what was going on with video signals and video technology at this time in the industry. But before we get there, I do want to take time to thank the sponsor of this episode, PCBWay. PCBWay offers low-cost, high-quality PCB manufacturing and a whole lot more. They offer flexible and rigid-flexible PCBs. They offer surface mount assembly. They offer high-density PCBs with up to 60 layers. They offer aluminum PCBs, and they also offer custom metal and plastic parts that need to be CNC milled or 3D printed. So check out PCBWay for all your PCB manufacturing needs, and I thank them for their support of the Retro Hack Shack. I actually found this nice little blog over on a website called the T3 Interactive Blog from 2016. I'll link to this article. It does a pretty good job of giving an overview of CGA, EGA, and VGA. Basically, CGA was released in 1981 and had 4 colors, although there was 2 palettes that you could use. So you could get kind of more of a brown palette, or you could get the standard, like what you probably used to with the cyan and magenta colors. So you could pick 4 colors basically and show those on the screen. And then EGA came out about 3 years later in 1984 and expanded the palette so you could have 16 colors on the screen in most of the modes. So that was definitely a step up, and we'll see that as we start testing out this monitor. And then finally, VGA came out in 1987, and it really expanded things. At first, just going to 256 colors that you could display on the screen, and this was because VGA was analog, whereas CGA and EGA were digital. So analog, you could do color blending, so you could get between a couple of different colors and really create this larger palette without a lot of extra heavy lifting on the part of the graphics card. So things changed from digital to analog and added a lot more colors. And then of course, in the years following, there would be SVGA, so we would expand the number of colors and expand the resolutions more and more and more until we get to where we are today. But that's the basic difference between these. And there's a really good example here of word tris, and you can see the variations here between CGA up here at the top, EGA in the middle, and VGA at the bottom. And it's kind of interesting for this particular software, the VGA mode actually doesn't quite look as good as EGA, but in most cases the VGA mode would have looked much nicer and had so many more colors that it would have looked way more realistic. Of course, the problem with all this is that people didn't just throw out their computers, so they would expand their computers. If they had a CGA card, they may have upgraded that to an EGA card and a VGA card. So by the time you get to VGA being released, you had to create a monitor that would really fit the bill for any 3 of those situations. And so vendors came up with monitors like the next one I'm about to show you, which had multi-sync capability and mixed digital and analog capabilities. So let's take a look at this next monitor and see how it handled all these different resolutions and standards. All right, well, now we're on to monitor number 2. This one is similar, I believe, in age, although it is a different monitor and it's not nearly in as good shape, at least externally. A lot of dust, a lot of bugs and things on it. But I think this can be cleaned up, especially if we find that it's working. This is a Nanao, not sure how to say that, Nanao 8060S. Taking a look at the front, we've got the power button, and there is a nice little notification or badge up here at the top. It says TTL analog multiple scan. Yeah, that's a little bit better. Frequencies between 15 kilohertz and 35 kilohertz. And it's got TTL and analog here. And I'm guessing that the LED here changes from orange from TTL to green for analog. So that is really cool. It also has some adjustments down here for brightness, contrast, horizontal size and vertical size. But what's interesting to me is this knob right here, which it says switches between, I believe, amber, color, and black and white. And if we move that switch, yes, indeed, it does have 3 positions that I can move that to. So it's not a pot, it's actually a switch. And you can set that up. I'm going to leave it in color mode for now, but you can actually move that between amber, color, and black and white. So I'm really curious to see what that amber mode looks like. Similar to the other monitor, there is a screw here in the side. When you take this off, you'll have to take that out, and no label like there was on the other monitor that said cautions, check out the warnings on the back before you disassemble this thing. And looking at the back here, we can see a few things. Number one, this is a 14-inch RGB color monitor instead of a 12-inch. So this one is quite a bit bigger. We can also see that this was manufactured in Japan. I think if I remember correctly, this same company, Nanao, I read somewhere that they actually also produce monitors for arcades. So it's possible that if you were playing arcade games as a kid in the early to mid 80s, you may have been using this company's monitors as part of that arcade machine as well. And this monitor looks like it was produced a little bit later because I do see a manufacture date of July 1987. We've got the power cord over here on this side, and then over here we have a similar system to what we saw with the other monitor. There is just a 9-pin input here. Because this is so hard to see, I just decided to take a quick picture of it. But we do have a switch here on the back for analog versus TTL, so you can switch that back and forth. And then there are several different modes here that it looks like it support. Here's an IBM 16. So I'm guessing that this does support EGA. That's something that we can test out. And then there's a mode that just says B or 8. Yeah, 8. So that must be CGA. There's an AT&T 16, and then there's a 64. So various color modes that you can set based on this switch here. It looks like you can go into a manual mode if you leave that out, or you can push it in for a preset mode. So I'll have to take a look and see how that all works. But yeah, it does look like perhaps there's some jumpers or 2 jumpers in there. So on is 8, off is IBM 16 color, on is AT&T 16 color, and then off is 64 color. So quite a bit of variety there that you can actually use this monitor for. You just have to know how to set those dip switches. I've got this plugged in. Let's go ahead and power it on and see if it fires up. Yep, I heard high voltage. Got static on the screen. Now I don't have a raster, but this is set for TTL mode. Let's go ahead and, before I actually turn on the computer, let's turn it over to analog mode and just see if this little LED changes to green here. Yep, and you can see it flicker, so now it's in analog mode, and it is definitely green. I love that indicator on the front there, so you don't have to go in the back and see, what the status is of this switch. So let's turn it back to TTL mode. There we go, it's in TTL mode. So yeah, I mean, at least we have high voltage. Let's go ahead and turn on the 5170, see if we get any graphics. And I did set the dip switches in the back to what I believe is CGA mode, that 8 color mode. So let's go ahead and see what we get. Okay, got a flicker. The video signal looks like. Yep, there we go. It's counting up. Looking good. I will say it is nice to have this 14-inch size. Does make a big difference, especially to my old eyes. But yeah, this thing is just working. Man, picked this up at e-waste. I can't believe that something like this was going to be thrown out. Let's go ahead and go into check it and see what happens. And the video graphics mode all come up just fine. It still doesn't do, for some reason, Check It 3.0 still doesn't do, at least with this card, the color test, which is really weird. So I'm going to guess here that Bard's tail is just going to work just like it did with the other one. But let's go ahead and try that. Yep, there we go. Bard's tail looks fine. Now I've got the brightness and contrast turned all the way up on this thing. So it appears that this particular monitor has probably seen a bit more use, and maybe the CRT is a little bit worn out. But with everything turned all the way up, it does look pretty good. Oh, interesting. The horizontal size is also a switch. So you can just crank that up, but it doesn't look to be a potentiometer. It's actually a switch. I wonder how that works. It does look like maybe we need to adjust this just slightly so that it can be centered on the screen. There we go. There's a horizontal and vertical position on the back that I forgot to mention. But now this is actually nice and centered and looks pretty good. If we wanted to make things a little bit more symmetrical, could take this down a notch like that. There we go. Now that's looking really good. Now this isn't the best graphical test on here, but the colors look good. The brown looks good. That's always a good test. And yeah, you can see I'm changing directions. It should throw another graphic up here on the screen. The Dark Priest is attacking me. I'm not going to go ahead and play through this, but yeah, colors and everything are looking really, really good here. Okay, now I've gone ahead and switched over the card back to EGA mode, and in the back I've set the dip switches to be that IBM 16 color, which I assume is EGA mode. So let's go ahead and see what happens. Let's see what Check-It does now. Now that I'm in EGA mode on both the monitor and the card. Is it still going to give me the weirdness, or is it going to actually cooperate? No. It looks like it's black and white again. Now this is mode 10H. Shouldn't this be blue? I believe this should be blue. Yeah, and then it just exits out. So weird. Now one thing I do want to see while we're in here is what difference this switch makes, the amber color black and white switch. So I'm going to go ahead and switch this over to amber. Oh, that is awesome. Hang on, let me zoom in. Oh, that looks so good. Check that out. Wow, that is so cool. I love this monitor and it's working really, really well. So that's the amber. This is supposed to be color, but Check-It isn't cooperating here. And then if we go over one more, that's black and white. If I get some color on the screen, then we can see what the difference looks like. Let me fire up Bard's Tale real quick. All right, so here is Bard's Tale in all its glory. This is what it looks like in color mode. Let's go ahead and switch this to amber mode. That's what it would look like in amber mode. Oh, that's so awesome. I love amber mode. And then let's switch it back to color, and then let's go back to black and white. So there's black and white. So it's emulating the black and white. I can almost see some color here. It looks like there is some color data coming through or something, but that's Bard's Tale in black and white mode, Bard's Tale in color mode, and Bard's Tale in amber mode. Oh my word, I love this monitor. All right, so just because I couldn't let this go without actually figuring out what was going on, I was pretty sure it was the Check-It software. Sure enough, I downgraded Check-It to Check-It 2.1, and blue screen. This looks normal with white letters. This is what I would expect to see on CGA or EGA. So yeah, it was just the Check-It program that for whatever reason was screwing up. I don't know why, but now everything looks okay. Still get the same readings from the system. Everything looks fine, but let's go ahead and go into the video tests and check out the graphics and see if it actually brings up the color palettes like I'm used to. Again, really good detail there. And now we get the colors, the CGA colors, as you would expect. This is what I would have expected to see before. I'm sure it works fine on the other monitor too. It's just I was using Check-It 3, and Check-It 3 apparently either doesn't do these tests or the version that I have is all screwed up. Anyway, this is all looking great. No problems whatsoever. Now we're into the EGA tests, and the brown looks good. That's what I always check for, because if it doesn't do that blending well, you're going to get weird results. But that looks good, and there should be one more here. There we go. The high-res colors on mode 0EH look great. No problems. This monitor is working well. I'm not going to go back and do the other monitor because we saw that it worked with games, with Bard's Tale in particular. So yeah, the color's working on that one too. Both monitors look great. This one's a little bit bigger. It looks a little bit nicer and goes from CGA all the way up to that 16 color configuration. So this is definitely a very cool monitor. And we get the color purity test. There's the red, green, the blue. Looks wonderful. And we're back to the menus. All right, well, this monitor is so special. I wanted to see if I could also test some of the higher resolutions, and that gets us up into the VGA realm. So I went hunting through my card collection, which is vast at this point, and I found this card here. This is an STB VGA extra EM card. And you can see it's got a lot of memory over here built in. It's either 256 or 512. I can't remember. It's got a lot of ROMs on board that say VGA EM. And it's got 2 ports back here. One is a 15-pin VGA port, and the other one is a 9-pin port. So I don't know if this is just VGA or if it also does CGA and EGA as well, because there are these dip switches right in here. I don't know if you can see those, and that is the exact configuration that you would have on an EGA card for EGA graphics. So I spent a couple hours looking for the manual for this card. If you have it, please let me know down below. I couldn't find it on Vogons, couldn't find it on Internet Archive, couldn't find it on a search. I found references to it in a scientific publication, but couldn't find the manual itself. And so I don't know what these dip switches do for sure. And there's also another jumper down here. I don't know what that does. So I'm just going to have to play around with this and see if I can get it working. But one thing I do know is that this monitor is probably the best case scenario for getting this video card to work. And if we can get it to work, we can see if it does some of those higher frequency ranges and VGA, which of course is analog and not digital. All right, well, I've got that video card installed and it is apparently at least working, right? Because I am getting text on the screen, so that means there's nothing terminally wrong with that card. So it is working, but let's go ahead and run it through, check it, and see what happens. Okay, and already this is not a good sign, and I'm really starting to think that Check It is just not able to recognize every card exactly, but let's go ahead and see. We'll put it through its paces. When we look at the configuration, it does come up as VGA, and it does show the EGA switches. So it recognizes at least that this is a VGA card, even though we're currently looking at a digital signal. Remember, over here on this side of the monitor, when I'm in TTL mode or the digital mode, you can see the amber light. And if I'm in the analog mode, you can see this will turn to green. So yeah, it's definitely in the digital mode, and it is looking like EGA basically card here that's working out of the digital output of this card. Now, interestingly, again, once we go into actually testing the graphics mode, then, you know, this should be black and white. I don't believe it should have this blue color, but, you know, I haven't tested every card in the world, so I don't know. Mode 12 looks really good. And that's it. So no actual color tests again, like it did with the other card, the dedicated EGA card. So I don't know exactly what's going on with Check It. So I think I need probably another testing software to use with this thing. And I also want to hook up to the analog, the VGA port, and see what we get on this monitor. All right, so now I'm going to try another program. This one's called Video Test Bench, and it's really meant to test monitors. It even has burn-in cycles and things like that. It's really getting back to the original purpose of this video, which was to test out these monitors, but it will also give us an indication if things are looking correct on EGA and CGA without necessarily going into all of the various modes. Because what I really want to see is what the colors look like coming out of this card and what they look like on this monitor before we switch over to analog. So if I go ahead and run this, VTB, Video Test Bench, FR, final release, 4.5. And there we go. Here we see Video Test Bench version 4.5F, whoops, which is final. It went off that too quickly. It's in the VGA menu right now because I think it detected that this was a VGA card. But if we do 0 to exit, it brings us back to the main menu, and you can see there's CGA, EGA, VGA, mono, and in the VGA menu, there's even SVGA. So with this particular suite of utilities, you can kind of get a good idea for everything from MDA all the way up through SVGA if this monitor supported it, which it doesn't, and you can test all of those things. So since we're running an EGA, if we go into the EGA menu, we can see there's a bunch of things that we can pull up. So there's crosshatches, mode switches to test how fast the monitor switches between modes, and there are also color bars. So let's pull up the color bars, and there you go. You can see that we've got all of the EGA colors that we would expect. There's a black bar over here, which is why it looks like there's nothing here. There's a white bar over here, and we've got everything in between, including brown. So that's a really nice way to at least test out the color patterns here when they're not coming up in Check-It. And we can pull up the crosshatch. I do have to have this a bit skewed. I think the focus on the deflection yoke in the back is either a little off or whatever, because you'll notice on this side of the screen, when I move the horizontal position over, you can see it kind of right here on this side of the screen, it kind of trails off. And it'll do the same on the other side, but it won't have that little bendy thing because it's, I think the position of the yoke is just slightly off so that it cuts off a little bit early on this tube. It should be shifted this way a little bit. But because I can move this, I can just move the crosshatch over a little bit. And yeah, you won't even notice when you're typing or playing games or things like that. Another cool thing in this crosshatch testing mode is that you can change the color, at least in EGA. So I can do a red mode, which kind of to me looks a little bit like Airwolf, which is kind of cool. But then you can change it to blue or green or cyan, magenta, yellow, just by pressing the first letter of those colors, and it will change the crosshatch around. So you can get a good idea kind of thin colored lines on this crosshatch test as well. And there are more tests, but what I want to do now is switch over to VGA mode. We'll turn this to analog, and we'll see if this thing actually works as a low-level VGA monitor. So in order to actually hook this up, I'm using one of these VGA to 9-pin converters here. I've got a bunch of these over the years, and it's pretty simple to do. I think there's just a few resistors and things in here. But yeah, that's what this is. So we'll hook this up because on the back of this monitor, it's just got that DB9 port on there. So I need something that will go from the DB15, which is on the card, to the DB9 so we can see if this will work. Now I'm still in digital mode right now. You can see the amber light there on the monitor, and while I don't recommend doing this, just for demonstration purposes, I do want to go ahead and hook this up very briefly to show you what happens if we hook up the VGA signal while we're still in digital mode. And there we go. We get these weird colors and things depending on what's on the screen because the signals obviously don't match. It's trying to interpret them. Don't want to leave it like this because it could damage things. So I'm going to go ahead and switch the switch now over to analog mode, and you'll notice this light turns green. Boom. And we get back to the screen that we were on. So we're now in analog mode, running VGA out of this card into this monitor, and it seems to be supporting it really well. Okay, hopefully the flicker should be reduced now or eliminated. I've changed the speed on this to match the refresh rate here of 35 kilohertz. One thing I will say when I noticed when I went into the VGA mode, the analog mode, is that somehow the screen has shifted a little bit, and I've got to adjust the horizontal position a little bit more to bring this back onto the screen because it was rolling over here. So kind of weird, but now we can exit the EGA menu and go into the VGA menu. And now we have a similar menu. We can go ahead and look at the color bar. And there's a bunch of options here, of course, because this thing goes way up to various resolutions here. Even though the monitor probably won't support all of them, we can at least test them. So if we select number 1 for 15 colors, now this monitor is putting out that nice array of colors that we saw before on the EGA test, the 16 color mode, but it is got black over here, which is why it looks like there's more blank space over here, but it's got a black bar here. So yeah, that's looking pretty good. We can try the 256 color mode, but I don't think this card has enough memory to support it. And indeed, I think this is supposed to be populated down here. We do get nice shades of gray, and we've got the 16 original colors here. But you can see when we start breaking those out down into 256 colors, we're not really getting the different colors in some of these boxes. Some of them we are, some of them we aren't. So it's really the limit of this particular card running on this monitor, but it looks like it almost supports all the colors in the 256 mode as well. A lot of other great modes in this video test bench software to test monitors specifically. You can do RGB stripes, you can do 16-step grayscale. Let's see what that looks like. There you go. You can see on both edges of the picture what it looks like, and you get that really nice grayscale build out. That's really cool. Really great software to test monitors like this if you're not sure of their capabilities. And they even give you an emulated NTSC test pattern here. We can put that up, and you can get something that might look more familiar to you if you were used to seeing a test pattern like this as you're testing out these monitors. Anyway, overall, this monitor is looking really good with all of these tests. I don't get to test the various DOS modes like we did in Check It, but at least I can see that the colors are looking good on the monitor, and the card is indeed, seems to be working just fine as intended. All right, well, this episode would not be complete without at least playing one game to see what it actually looks like on these monitors. I don't know about you, but that's how I can usually tell if a monitor is good or not, is by seeing a game that I'm familiar with, playing that on there, and then I can usually get a good idea for if the monitor is good or not. In this case, I'm going to be using Planet X3, and the nice thing about that is it does support pretty much all the video modes. So we can play this in EGA, and then we can switch to VGA and play it in VGA and see what it looks like there. So first, let me go ahead and fire up the EGA mode, because that's what I'm currently on. Here we go, and I am running this off of floppy, so it may take a little bit to start. Let's select PC speaker. Sounds good, and here we go. Planet X3. So now we know what this looks like in EGA mode. It looks fantastic, of course. We can go ahead and start the game. And here we go. We can see we've got, EGA graphics looking fantastic. So that should give us an idea of what it looks like in EGA. Let me switch over to VGA, and you can see what this looks like with VGA mode. Well, I did want to show the opening screen for comparison too. This looks fantastic compared to EGA, but let's go ahead and get back to that main starting screen. And there we go. There's the cut. You can compare these. Maybe I can put them side by side. But yeah, VGA just, of course, blows EGA out of the water. I mean, this just looks fan-flippin-tastic. So the good thing is this monitor does work really well with both EGA and VGA all on the same card. Definitely going to hang on to this card because it'll help me test more monitors in the future. Now, while this monitor isn't in terrible condition, it does have some little scuffs and things that you can see there. You know, it's been moved around a bit, so there's some dust and some little cleaning that needs to happen. So I'm just going to go ahead and take care of that real quick. Nothing major, no montage needed, but I am going to clean this thing up because it's quite a monitor. And here we go. I was able to get all of the dust and dirt off at least, and all those black marks. There's still some scuffs and scratches that I couldn't get off, but all in all, it's 100% better looking now that I've taken just 15-20 minutes and cleaned up all of this stuff off this monitor. So it's ready to use for future projects. Well, I've got this monitor, the 14-inch one, all cleaned up, and it actually looks really good. It came out a lot better than I thought it would. And so, yeah, I'm really pleased with the results, and I'll probably be using it more on the channel. Now, one thing I noticed when I put these two side by side, put the computer back into CGA mode and ran Planet X3, I can easily tell that there is a difference between the two monitors in terms of saturation. Now, that may be because the saturation wasn't set correctly initially. It could be because the CRT in this particular set is a bit more worn out over time because maybe it was used more heavily. I'm not exactly sure, but I can't get to the color controls in this monitor without taking it all apart. So I'm going to do that after this video is over. If there's anything really interesting, I'll add it in editing, but I think it's just going to be a matter of finding the correct settings inside the unit and being able to tweak those to make the color to be a bit more accurate. This one seems to have really good deep color, and I can actually, there's controls on the back where I can actually tweak those color settings without opening the monitor up. The difference in the color becomes way more noticeable when you move from the magenta color, which is on screen now. If we change the CGA color palette to the more amber orange tones, orange and brown tones, you'll see the difference. So let's do that now. So now you can see the difference. This particular monitor still looks kind of pinkish, while this monitor is displaying the correct kind of dark amber color that you would expect with that alternate CGA palette that you can see. So this monitor is really cool. It has a lot of functionality, but the colors need to be tuned. This monitor, which I don't think was used very much, definitely has much brighter, vibrant color and more accurate color, at least to my eye. Let me know what you think in the comments below. Which one of these monitors would you choose? I know for me, I think I'm going to be going with this one just because of the functionality. This one is just a really solid RGBI monitor that could be used for a lot of different things. I don't have an IBM 5153 monitor, for example, so I'll probably be using this one quite extensively until I find that elusive 5153 that I'm looking for. So let me know what your thoughts are in the comments below. I do want to thank all my patrons over on Patreon for supporting the channel. Their support has really helped a lot while I'm in between jobs and kind of figuring that situation out. But if you like more videos about IBM systems or monitors in general, you can actually check out this playlist I'm going to put over here in the corner, and I'll see you in that video next. Thanks for watching.
End of line.